Okay, you're going to take a look at the homework problems from Chapter 2, the second part on multiple vectors, and start off with homework problem 1, where we're going to find the resultant horizontal and resultant vertical components of R, and also its magnitude and the angle beta that it makes relative to the horizontal axis. So let's just take a look at what's going on here before we start solving things. This first vector, we're going to start at the origin and start with our first vector here coming off of it, follow our trail along. We'll call this vector A. And this vector makes a 65-degree angle from the horizontal, and its magnitude is 12 miles. Then coming right off of that, I have vector B, which comes right at the tip of that down to here. It's got a magnitude of 15 miles, and it's making a 40-degree angle with this vertical here. So it's a 40-degree angle there. And then we have our resultant. If we started the origin and we wanted to get to where B wound up, we would just kind of do the quick run here. And so we'll have some magnitude for that resultant and some beta that we're going to measure relative to the horizontal axis. So our beta is going to be there. All right, so let's go ahead and break this problem down into its parts. Let's start with vector A. We're going to go ahead and look at the horizontal and vertical components of vector A. So we're going to solve for A sub h and A sub v. So the first thing I'm going to do is just go ahead and draw those components on here. My horizontal and vertical components, I'm going to go ahead and just finish a triangle here. So my vertical component is going to come up along this vertical axis. We'll call that A sub v. And the horizontal component is just going to go straight over to the end where A ends, and that's my A sub h, my horizontal. And I can just take a look at those while I'm drawing them on and think about what kind of magnitude they're going to have. A sub v is going up from the origin, and so we're going to say that's positive. And A sub h is going to the right, and so that is also positive. So just something to think about before I actually start solve for their numerical values. My B, I'll go ahead and put a B here, vector components here are going to be a horizontal component, vertical component that's coming down here, B sub v, and also a horizontal component that meets up at that vector, at the end of that vector there. Now, B sub v, using that same frame of reference from the origin, that's going to have a negative value, and the B sub h is also going to have a negative value since it's going to the left. And this makes sense if we think about our components of R here, because as a resultant, we're going to have some R sub v and an R sub h. And they're both going to be pretty small relative to those other two. And we can see that R sub v is going to be negative and R sub h is going to be positive in this case. So just kind of defining those and drawing them in just to get a feeling. And you can see I'm kind of not too well lined up here, but it just kind of gives me a general feeling of what's going on in this drawing. All right, let's go ahead and solve for these components then, starting with vector A. I'll go ahead and start with that horizontal component. I can see that my angle is coming down here, and so when I compare this A sub h to my angle, thinking about my triangle here, A sub h would be the opposite leg to this triangle. This would be opposite to this angle, opposite, and this would be the adjacent leg to this angle that we know. So since this is opposite to that, I'm going to go ahead and use sine to solve for that. So A sub h is going to be 12 miles times the sine of 65 degrees. And I put that into my calculator, and I'll get 10.9 miles. And we'll put a positive on that guy. And then A sub v is going to be 12 miles times the cosine of 65 degrees. This time we're looking at that adjacent leg, and that is going to be 5.1 miles. And you can check that in your calculator. Make sure you got that. And now we're going to take a look at B, vector B here, and see what happens there. Again, we're going to have to find the horizontal and the vertical components for B. Slide that up a bit. So my horizontal component for B, my magnitude of B is 15 miles. And then I have to take a look. Horizontal here is that adjacent or opposite to the angle that I know. Well, it's all the way over here. It is opposite, so I'm going to have to use sine again for my horizontal component, sine of 40 degrees. And when I do that, I get a negative 9.6 miles. Okay, I get 9.6 in my calculator, but I take a look at my b sub h is going this way, so it's got to have a negative sign in front of it. And my b sub v is again the 15 miles, but this time I have an adjacent leg, so I'm going to use that cosine of 40 degrees. And that's going to give me 11.5 miles, but again, that's in a negative direction. All right, so we found those components for A and B. Now we want to sum them up so we can find this R sub V and R sub H. Because remember, R sub H is just this A sub H and this B sub H added together. It's just that because B sub H is going this direction, I'm really sort of subtracting it. Let's take a look at what that looks like. So R sub H is going to be, like I said, A sub H plus B sub H, which in this case is my 10.9 miles. Okay, and then and I'm adding, but it's a negative 9.6 miles. Okay, so I'm adding a negative, so I'm essentially subtracting, and when I do that, I get 1.3 miles. And I can put a positive sign on that if you want to. You don't have to, just to remember what's going on there. And let's find the resultant in the vertical direction here. I've got this big B sub V here, and I'm taking this A sub V and subtracting this B sub V from it. So I'm going to wind up with some negative value here. But we still just follow the same procedure, A sub V plus B sub V, because if we've got the signs right up here, it's all going to come out correct in the end. So my A sub V is the 5.1 miles, and B sub V is 11.5 miles, but it's the negative 11.5 miles. So when I add those together, it's really like subtracting that 11 from the 5.1, I get a negative 6.4 miles. And again, if you want to circle the signs, just remember to put them on. It's really up to you. All right, so I have all the information that I need now to find my resultant and that resultant angle. So I'll just go to my formulas, or maybe you remember this. I'm going to use the Pythagorean Theorem because basically I know these two sides of the right triangle and I want to find this side. So I can use my a squared plus b squared equals c squared. Or in this case, we'll call it rh squared plus rv squared. And so like I just said here, my RH is 1.3 miles, and we'll square that. And my RV is negative 6.4 miles. And if you forget to write your negative sign in here, not such a big deal because we're squaring it, so that's going to disappear. But when you go ahead and do all that math, you should wind up with 6.5 miles. And we've talked about in class that sometimes if you have a little bit of different rounding, or maybe you find one of these using sine or cosine and then you use Pythagorean theorem to find the other one, you might have a little bit different answer than I do, but you should be in this ballpark to have the correct answer. Okay, so let's take a look at that beta then, as I'll just stick it down here at the bottom of the page. As we've defined it on our formula sheet, it's that inverse tangent of RV over RH. Okay, and let's just take a look and make sure that that's going to make sense here. It's going to be my RV over my RH. Remember, tangent is opposite over adjacent. So what I'm really finding here is, you can think about it this way, this angle here, but remember from our geometry that this angle here is equal to that angle. So that's going to give us that same value. So we'll take the inverse tangent of negative 6.4 miles over the 1.3 miles, but remember how we talked about in class, we don't really have to worry about this negative sign here because we don't want to get a negative angle since we know where it is on our frame of reference. And when we do that math, we wind up with 78.5 degrees. All right, so that is our answer for beta. That's our answer for R. And I don't know if I showed this or not, if I dragged it down, but showing that we were using that inverse tangent to solve for opposite over adjacent. So this is the angle we were finding, even though we're technically looking for this beta here, but remember from our angle reasoning that these two angles are going to be equal. So that's going to work out for us. Okay, so there is the solution for homework problem 1.